Hello and welcome to another Bitwise homework session here. Last time we did some lexing, so today we're gonna do some parsing. One thing I've been thinking about is I think technically these need to be like you need to handle the case where you don't have an operator at all, like the top level one here does. Something like this. Yeah, something like this, I think. So let's reference the book he linked us. Oh, and I am dropping frames. Sorry about that. Okay, it looks like it was just a little blink out, so hopefully there won't be too much of that. I apologize. So they do procedure expression, procedure term, procedure factor. So we're keeping a list of identifiers. And so they're switching over what the symbol is. Recording it in their list. Getting the next symbol. And so in some cases they call the outermost procedure expression. Okay, so I don't really know what to call these things. So basically, we're going to do a get sim. And then I guess we're going to switch on the symbol. Let's make it a final switch. Or actually, never mind, because some of them are going to be handled at higher precedence levels. Although maybe we want to handle it here and then oh, and then the question too is, where do literals fit in the mix? I don't remember from pairs code, which is probably good because that means we'll learn more trying to figure it out ourselves. I felt a little bit kind of gypped in a sense that when I did the lexing and when I wrote out like this stuff, I more or less remember what he did on stream. And I think it's more rewarding to try to figure it out yourself, but I mean, either way we learn, so. So This one's going to be subtraction, but then it could also be unary minus. So I'm still not totally sure exactly how we're going to do this, but we're going to figure it out. So let's start with what we do know, I guess, which is conversion from a string to an integer. Okay, so we have the actual string in ID after we do a get sim. So we need like a structure to represent the thing we're parsing, right? Like something needs to hold the integer in the case of a literal, for example. Although it seems like worth isn't actually converting the literal into anything. Like he's just keeping a list of identifiers as far as I can tell. I'm not sure I totally follow. So like if they get a left parenthesis, they get the symbol, then they parse an expression, they don't record the symbol, right, in the parse tree. They're only recording identifiers and literals, it looks like. But so when they get a left parenthesis, they get the next symbol, and then they parse the expression that that symbol is leading to. And when they hit a right parenthesis, they just go to the next symbol. Or wait, this is within the tree for a left parenthesis. Right, so they're saying they get the next symbol, parse the expression, and then there needs to be a matching right parenthesis after they've parsed that whole expression. And then they just go to the next symbol. Similar thing going on here for our brackets and for braces. Okay. So this is saying while symbol is less than bar do factor, which is what we just read. So what is bar? Oh, bar is like a pipe, a vertical pipe, presumably. So that's saying well, the symbol is any of these. Then you do factoring, which makes sense because factoring handles these. Okay. So if you get a bar, and this is parsing EBNF grammar, right? So if you get a bar, then you get the next symbol and then do a term which does this, right? This one's saying okay, so this is what we were looking at. When you have a production, you need an identifier followed by an equals, followed by an expression, and then a period at the end. Okay. I'm just trying to wrap my head around when things get recorded, because it seems like, you know, he's not really doing a tree structure, parsing this into like a tree. He's just recording things into like a list of identifiers. So if we go to the homework, day 2, right, ultimately our goal is to generate an S expression that looks like this. So like walking through this in our head, what needs to happen, right? The first thing, the first symbol we get is a literal. The next symbol is a multiplication, and then we get another literal. And do we have a way to look back on the previous symbol? I don't think we do, right? So if we get a symbol and it's a decimal int, then the expression has to either just be a decimal int or there has to be an operator, right? I'm not really seeing how you do this without like a tree to represent the, like a parse tree. I think at this point I'm gonna take a look at what pair did. Because I'm feeling a bit stuck. So it looks like he actually does the integer conversion in the lexing stage. That's interesting. So here we can see a look at his take on the grammar. So like he does parse expression 0, and the first thing he does is he does a parse expression 1. First thing he does in parse expression 1 is parse expression 2. Okay, so that makes sense then. So then our literals handled at really high precedence. Yeah. He puts them way at the top. Okay. That's, I guess, what had me confused, was I didn't know where to put that on the precedence stack, so to speak. Okay, so using that information, let's go back to ours and see if we can make some headway. So the first thing we should do is not this stuff. So I wonder if these, I mean, in his, he's returning an int, but he's doing like evaluation too. Whereas I want to just generate a S expression. So I feel like what I want to do is kind of have like a stack structure where I say like, you know, this returns components of what I'm trying to build up. Although this could end up being more than one symbol, definitely, to say the least. I guess, I feel like I want something to represent an expression. I guess an array of symbols is an expression. Although maybe I don't really want the symbols, I want the identifiers. You could have like a struct that holds both of them. For now, let's just make a thing. So we're going to have an array of strings, where each string is an identifier. So an array of identifiers makes up an expression, and an array of expressions is like the stack that we're building up. So we're going to store the ID before we overwrite it. So I want to just start very basic. We're just going to do plus, and we're going to do literals. So we're going to handle literals up here. All right. So we're going to need to get sim here. Oh, right. Get sim doesn't return. It puts it in the global sim and ID. thing is, maybe I don't want this. Maybe I don't want the, the parse tree I'm building up inside expression 0. So the idea here is I'm representing my parse tree like a stack machine, but like it's backwards. So like the S expression plus and then a number and a number is represented as an array of a number plus, right? So we're gonna see how that goes. So let's make another simple test input. Let's just start with a number and see what exactly happens. Undefined identifier decimal int. Undefined identifier result 146. Oh, right. I guess we don't even need the return statement anymore. $154 cannot append void. Oh, right. Right. And then 166, 167. Okay, so let's switch it to do the proper test. Okay, so we got our 5. Now, what happens if we do 5 plus 4? 5R plus, that is what I wanted to see. Let's stick another ooh, 144. Okay, so what happened here? We got to expression 2. And we hit something that wasn't a integer. I should really write out as we're constructing the thing. So it handles the 5, the 4, the plus, and then it's the assertion failure. In expression 2, what comes after? Oh, because it hits another plus. So it doesn't like the chaining pluses, is the problem here. It shouldn't be expecting a number here though. That's a problem. Let me think about this. So we start out, we get a literal, we grab the next symbol, we see a plus, so we parse the expression, the next expression, and then we add the plus to the stack. And then we drop back in. And so the problem here is when we come back around, so I think I want to change this to a return. And then this to a break. And then down here, if we get this far, try an expression 0. So this parsed as add 7 and 32, add 5 and 4, but we didn't get a final add. It should be, there should be an add for all of these. Like there should be another plus on the end here. And technically, if we're parsing left to right, it should do 5 plus 4, and then it should do that plus 32. The problem is that once I finish a round, it doesn't treat the stuff I've built up as the left-hand side of an expression. Oh, that is not what I want. So why did that infinite loop? We hit the 5, the 4, the plus. So then it should be hitting another plus. So it should try to parse another expression. I'm not hitting the default case, am I? I am. What's the symbol it's looking at then? An integer. It should be this plus sign. I'm confused. What is going on here? It's still on the 4. Okay. So we need to advance the symbol here. Okay, this is looking a bit better now. So we have 7 and all this. We have 32 and all this. We have 4 and this. Now the other thing about this is because of how I've done it, I've kind of parsed it backwards, like it reads right to left. And I think that's not exactly what Pear wanted. Like, it's technically correct, but I think it's not what Pear was really asking for. So yeah, if I were to parse this, it would be backwards. So I've managed to stumble my way into a working parser, so to speak, or a very, rudimentary first take on one, but it's not parsing the direction Pear was hoping for. So I want to study his code some more. So the first thing we're doing is parsing all the way up. So let's just say we have the same sort of thing that I'm doing here. So if we have 5 plus 4, right, we'll climb all the way up to here. We get an integer. We get the next token, and we return the value. So that gets returned back down to here. but we're not doing either of these tokens, so it passes it back to expression 0. So the end result is we get the number of the literal in this integer, and then the next token we're looking at is plus, right? So we get the next token, and then the R value is parse expression 1, which again wait. So we get 5 plus, this advances past the plus, so we don't hit this, right? We skip past it. We're looking at the 4 in 5 plus 4, right? So that jumps all the way up here, returns this back down the chain. So we end up with rval equals parse expression 1. So 4 is here, 5 is here, and then we say if op is plus val plus equals rval. So that's actually, evaluating it. But I don't want to evaluate it, I want to build up the tree. So when we've done 5 plus 4, next time around, oh I see, because it'll loop back. Right. I think we're gonna need, or at least I want to represent it as a proper tree, because we're doing a parse tree. So essentially, let me draw it out in Milton, because I'm more of a visual guy myself. Hello, Croatia. The stream might be a little bit laggy, a little bit of buffering or dropped frames, because my network doesn't seem to be stable right now, so just a heads up about that. But I'm working on the Bitwise homework. The parsing. I got it to parse backwards. So like this is technically correct. I parsed it like a stack machine. So this is saying plus, and then what you're adding is 7 and all of this. So you read it right to left, right? So technically this is parsed correct, but it's not in the right ordering that Pear wanted. Ah, interesting. So I think what I'm going to do is actually represent this as a tree. And so my example is 5 plus 4 plus 32 plus 7. And what I want this to parse to is going to be this, right? That's what it should parse to. So with that in mind, when we're parsing left to right, what's going to happen is we're going to get this innermost, like we can get this pretty easily already. And what I'm going to want to do is say, like, this structure is going to be op, left-hand side, right-hand side, right? And then, so what's going to happen is this is going to be plus, this is going to be 5, this is going to be 4. But then, as we continue to parse, we hit this plus, and so we're going to make a new and then what we're going to do with the left-hand side is we're going to link that to here. And then right-hand side, we're going to parse 32. Then we keep going, we hit another plus. We're going to make another one of these. We set that to plus. We link the left-hand side to the previous node, and then the right-hand side we parse again. We get 7. So then this becomes 7. And then to read this thing, you start with the latest node, and so you would print, the plus, and then you would read the left-hand side. So you start printing that, plus, and then you follow the left-hand side. You start printing that, you get a plus, left-hand side, 5, and then this one, this should be a 4. So then you get the 4, and then you jump back here, right-hand side, 32, and then you jump back here, right-hand side, 7, and so that's how you would print that structure out. So the left-hand side and right-hand side are either going to be a literal or a node. So that's like a union. So a node is going to have the operator. So for now, I'm just going to star that as the string, but we might want to make a type that contains the symbol and the ID. But I'll just say here in our little diagram that this is an abstract, operator type. And then, like I say, we have this union, and then we have another one of those unions. So that's our data structure, basically. So let's code that then. And we should in D, I believe std variant provides like a type for unions that are tagged. Discriminated unions, is that a tagged union? Something of that nature. having spent a lot of time recently doing C code and assembly and stuff like that, when I go back to D and I want to do more high level stuff, I find myself thinking, rather than staring at the docs to find the thing that I want, I could just spend that time typing the thing in like the lower level style. Because like for the unions, I can just have like a struct that has the type. So what should we call this thing? I'm glad to know I'm not alone. So for now, this is just going to be a string. Something to this effect. And then we're going to have a node. And the operator we're going to represent just again as a string. And we can change that later. I guess we can encapsulate this within node. Just call it member. Okay, so I think what I want to do is have an anonymous union. Groifa says, I actually really like high-level abstractions, but often I prefer them after I make them myself, according to the specific way that I like to do things. Yeah, I can see that. Everything's better when you make it yourself because you know it inside and out. Um, I think that's part of that. And I like high-level abstractions when I'm just playing around with code, when I'm not actually like doing serious development. Like this is a perfect example where I'm just doing homework. I'm just trying to learn about, you know, the construction of lexers and parsers and that sort of thing. That's a perfect example of something that I like to use something like D for, and I'm more comfortable, you know, relying on their standard library and all the language features and things like that, because you know it's a great environment to really rely on other people. So you don't have to implement every little thing yourself, and that can be very nice when you're just playing around with code. Another perfect example is like the build script for pcalc is a D program, because essentially all you want is a list of, you know, shell commands to run, but you also, as the, you know, your build system gets more complicated, you start needing to do some control flow and making decisions about what commands get run depending on certain things. And you know, any shell scripting language is absolutely awful. So it just makes sense to use a language like Python or D or anything like that to do a build script, in my opinion, and things of that nature. And so I use D for that, and it's nice because uh, you get a lot of nice features for free. Like, let me just take a little tangent here and go to my build script, right? So there's a lot of really nice things that you're getting for free here. Like, so one of the nice things that I really love is this getopt standard library, std getopt. And so it does all that, you like all the handling for your compile or your command line argument parsing. Like, so when I run my build script, I can say like dash dash release, right? And it will do a release build, or I can say dash R, right? And that's specified by this string right here. Like I just type that string and that it gives me that functionality. And I even have this string here. So if I say dash dash help, it'll print out all the options that my program has with their descriptions. And this is the description of the release option. So for example, so you see it gave me a nice help info, and like this is all for free basically. I just need to type in the strings, like I want something called release and the shorthand is R, and this is the description, and it does all the rest, right? Little things like that are just a nice, you know, a nice convenience to have. Um, and like it even does stuff like so the backends I have are defined as an enum, right? So there's the X11 backend and there's the XEB backend, and you'll see in my GetOps stuff there's this to select the backend. Ah, nice. Yeah, so this thing selects the backend, and like all I did for the GetUp stuff is I tell it like this is the thing that argument goes in, right? You just say you're passing it something that goes in this variable, this backend variable, and it figures out at compile time using introspection that the backend variable is of type backend, which is an enum that has the members x11 and xcb. And so you literally can type backend equals xcb, right? And that builds the xcb backend, right? Like what it did is it set the backend variable in my program to backend.xcb. Like it recognized that this string that you pass to your program is actually the name that matches one of the names. Yeah, the D is really nice in that regard. So it actually matched this name in the enum. And that's just a really cool thing. And it's like I didn't have to write that code. That's just in the standard library for me to use. So, you know, and then like to do issuing shell commands, like they have execute shell and stuff. So you can do all kinds of good high level stuff and not worry about the details. So if you just want to pound out a build script really fast, it's really nice to be able to do this sort of thing. And D is such a big language that has such a big, rich standard library that you can do pretty much anything you imagine that you would want to do, just like out of the box. So I'm not the kind of person who would hate on high-level languages. I think they really do have their place, but for like systems programming, I'd rather be close to the machine and building everything myself. And when I'm in that kind of programming space, I no longer want the high-level abstractions, because I'd rather be, you know, thinking about a very low level, like thinking on the same level as the machine. It really just depends what I'm programming. Am I programming a serious application, or am I just doing some fun scripting? That's kind of how I look at it personally. I think I'm going to make these classes instead of structs. So with this structure in mind, I'm just going to keep an array of nodes. So now when we get a decimal, we're going to say if we don't have any nodes, add a new node. Let's also make a type for empty so that we know so if we're empty, we're going to set our, that should be last member. Or I guess technically left-hand side would be null because it's a class and we have an allocated one. So let's change that to be Something to this effect. I might need to fully qualify this name. We'll see when we compile. Let's maybe pull this out. Okay, next. So if we get a plus, we'll do that. Although, let me think about this, because now we need to start chaining nodes together. So if we get the right-hand side, add a new node, and create a new node with the left-hand side set to the previous node. $145. Okay, so it didn't like that. I thought that was the syntax, but I guess I read the document wrong. $164. Oh, so it doesn't want me to new unless I'm the outer class. So I don't know what the idiomatic way to do this is. Just add a member to initialize it. All right. This is getting really ugly. I'm starting to regret nesting things. Can I say like some sort of literal like that? No. Okay, let's undo all the nesting. I'm not liking the nesting. That needs to stop. Get rid of all that nonsense. Let's just make this anonymous, make this an int. Get rid of this nonsense. Yeah, it got pretty ugly. How am I supposed to initialize the CDN? Let me go to the Programming in D tutorial. Let's see what they have to say about unions. Oh, so this is how you do it. Okay, let's just make it anonymous then. That's a nice little improvement. So they don't really give an example either. Doesn't look like it's going to be valid syntax, but we will try it. How about we just make two different constructors? 151. Okay, there we go. Didn't really pretty print it though. What's the thing we need to implement to get it to pretty print? I think it's toString. Let's just try it by doing that. Yeah, okay. So what we're going to do okay. Next, we want to do the same thing for node member. Oh, alright. See you, Crava. I'm going to stop soon too, and then I'll be back later tonight. Or wait, no. No, I won't be. Never mind. I'll be back tomorrow though. Okay, so we're going to say something like this. Or I guess we need to do Oh, that didn't pre-print the right because I made it an anonymous union. In that case, we're just going to print the value. It's not as pretty as I was hoping, but I'll improve this next time I stream. So we will continue next time. So what we got here is, looks like this one has an empty op, so that's not right. Left hand side is a node, which is plus. Left hand side is another node plus. Left hand side is another node plus. So we got the plus 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 5 4 32 7. So I mean, like, it parsed it right for the most part. But the formatting of my pretty printing is pretty ugly right now. We'll improve that in a bit. Or like, I mean, next time I stream. I guess we should change it to pretty printed as an S expression, shouldn't we? That's really the thing to do. So like, really, it's supposed to be like this. Oh, whoops, got rid of the wrong thing. There we go. So we're pretty close. We've got an extra layer, but other than that, the S expression is correct, right? So that's some pretty good progress today. And like I say, we'll continue trying to get everything going here in the next stream and getting rid of that that outer layer, testing stuff. Then we'll get to doing the bonus stuff, and we'll see where we go from there. So thank you guys for tuning in, and I'll see you in the next one. Stay risky, everyone.